All right, folks, at this point we have learned how to simplify square roots, and we have learned how to multiply, add, and subtract them. So today what we're going to do is tackle the last of the operations. So you are going to be dividing square roots. We will actually be spending a couple of days on this. So today we're going to do some pretty standard division problems. And then on Monday, we need to talk about some division problems that have a little bit of a twist to them. So that's kind of the approach we'll take here. Now, the good news is, for most square roots, dividing is a pretty easy process. And you're going to see that this is going to be a lot like what we did with multiplying. When you divide square roots, you're going to do the outside divided by the outside. You're going to do the inside divided by the inside. And then you are going to simplify the answer. So notice, that is a lot like what we did earlier with multiplying. You divide the outsides, you divide the insides, and then you simplify the answer. Notice that this does not require that we have like terms. All right, so let's do some examples here. First up, we are going to do 12 square roots of 60 divided by 2 square roots of 5. So 12 square roots of 60 divided by 2 square roots of 5. All right, so the first thing we're going to do is we're going to do the outside, which is 12, divided by the outside, which is 2. And we know that if we do 12 divided by 2, we'll get 6. And then we're going to do the inside divided by the inside. 60 divided by 5 should give us 12. So we're going to end up with an answer of 6 square roots of 12. Now at this point we will simplify. And we simplify the way we always do. So you need that perfect squares list in front of you. So you're going to have to find 2 numbers that will multiply to give you 12. And one of those needs to be a perfect square. So we know that 12 will divide by 4, so we're going to rewrite the square root of 12 as the square root of 4 times the square root of 3. Simplifying a little more, this gives us 6 times 2 times the square root of 3. And our final answer then should be 12 square roots of, oh, why did I say, yeah, 12 square roots of 3. We're good. So we divide the outsides. 12 divided by 2 is 6. We divide the inside. 60 divided by 5 is 12. And then we simplify this square root just like we have from the beginning. Final answer is 12 square roots of 3. All right, let's try another one of these problems. Let's try negative 14 square roots of 72 divided by 2 square roots of 8. All right, so in this division problem, first we are going to do the outside divided by the outside. Negative 14 divided by 2 is a negative 7. And then next up, we will do the inside divided by the inside. 72 divided by 8 is 9. So here's where we end up. We end up with negative 7 square roots of 9. Now, in this problem, we need to simplify the answer. So we're going to simplify the square root of 9. The good news is that is already a perfect square, so we are ready to simplify this. The square root of 9 we know is 3. So this becomes negative 7 times 3, which is a negative 21. So notice, if the number that's inside your square root is a perfect square, then you don't have to do all of that breaking down. Simplify it the way that it is. Now, for our last 2 examples, let's put some variables into the mix. Okay. So let's do the square root of x to the 3rd y to the 9th divided by the square root of x squared y to the 5th. Now, you'll notice on this problem that when we go to do outside divided by outside, there is nothing outside of either one of these square roots. So we don't have to worry about doing that step. We do need to do, however, inside divided by inside. And you know, I want you to notice here, since we're working with variables, that we need to remember from a while ago that when you divide x to the 3rd by x to the 2nd, that you subtract the exponents. So don't forget when you're dividing, subtract exponents. So x to the 3rd divided by x to the 2nd would be x to the 1st, and y to the 9th divided by y to the 5th would be y to the 4th. So we end up with the square root of xy to the 4th. Now, we have to simplify that answer. So remember, that means we're going to split it into 2 square roots. Now don't forget with variables that what we need are exponents that are even. We need exponents that will divide by 2. Now our x is being raised to the 1st power. That is not an even number, and I can't get an even number out of that. So my x to the 1st power is going to go into that 2nd square root. Remember, that is the one that we cannot do. So I can't do anything with that x to the 1st power. Y to the 4th power has an even exponent. So I can take the square root of it. So I'm going to put that in my 1st square root. All right, so here we go. To take the square root of y to the 4th, remember you take half of the exponent. So that's going to be y to the 2nd power. And then the square root of x cannot be done. So we leave that just like it is. So the final answer on this problem is y to the 2nd power times the square root of x. All right, let's do one last problem, and this one is going to kind of encompass everything. We're going to do 28 square roots of 16m to the 6th n to the 9th divided by 4 square roots of 2m n to the 3rd. Okay, so to do this division problem, we will start with the outsides. When we divide the outsides, 28 divided by 4 will give us 7. Now we'll turn our attention to the insides. (16m to the 6th n to the 9th divided by 2m n to the 3rd is going to be 8. M to the 5th n to the 6th. We divide our coefficients. 16 divided by 2 is 8. We subtract our exponents. 6 minus 1 gives us m to the 5th, and 9 minus 3 gives us n to the 6th. So here's my answer after dividing. Time to simplify that. So the square root has to be split into 2. And we begin our work with this 8. You need 2 numbers that will multiply to give you 8, and you want one of those to be a perfect square. 4 times 2 is the way that we should go with that. With our variables, we need exponents that are even. M to the 5th does not have an even exponent, but I can get an even exponent out of that. So we're going to do m to the 4th times m to the 1st. Notice still m to the 5th, just written a different way. And then, of course, n to the 6th already has that even exponent, so we put him in that first square root. No need to split him up. All right, simplifying here. I can take the square root of 4 m to the 4th n to the 6th. The square root of 4 is 2. And then when I cut my exponents in half, I'm going to have m to the 2nd and n to the 3rd. The square root of 2m cannot be simplified, so I leave him alone. And then you can see here that I can do my 7 times my 2m squared n to the 3rd and get 14 m squared n to the 3rd. And then that's times the square root of 2m. So notice that we divide pretty much the same way that we multiplied. We divide the outsides, and then we divide the insides, and then always we fall back on that simplifying skill that we learned at the beginning of this chapter. You simplify the answer as much as you can. I would encourage you to contact me if any of this is not making sense, if you're having trouble with any of it. So let me know if there's anything at all that I can help with. Now, like I said, Monday we will tackle some other division problems. And to kind of give you a preview of what that's going to look like, those division problems are going to be things like this. 5 square roots of 13 divided by 2 square roots of 3. Now you'll notice here what's going to make this different. When I try to divide the outsides, 5 divided by 2 would give me a decimal. When I divide the insides, same thing. 13 divided by 3 would give me a decimal. So on Monday, we tackle division problems like this that are not divisible, things that we can't easily divide. So we'll talk about how to handle that on Monday. All right, any questions? Let me know.